All right, our next talk is Dong Ma, who is going to talk to us about Oracle's Public Cloud DevOps practice.
Hello, everyone. Thank you for joining my session. Today, I will talk about how to leverage the OpenStack CI/CD structure into our Oracle Public Cloud DevOps development. In this session, I will introduce the OpenStack CI/CD workflow and tools, and what problems we faced in our Oracle Public Cloud China Data Center DevOps development, and how to leverage the OpenStack CI/CD into our operations. Okay, first to introduce myself. My name is Dong Ma. Currently, I live in Beijing, China. This is my first time come to New Zealand. It's a very beautiful country and with nice weather. It's more warm than Beijing. And currently, I work for Oracle as IT principal consultant at Cloud Operations China, mainly focus on the Oracle Public Cloud China Data Center DevOps development. Before joining Oracle, I worked for the Hewlett Packard Enterprise as an OpenStack software engineer, focus on the Jenkins and the OpenStack CI upstream contribution. I'm also a co-contributor on foss project, which is open source license analysis tools. Okay. Quick review of what I want to talk today. I will first introduce the OpenStack CI/CD workflow and tools, and how OpenStack structure looks like with this workflow. And then I will talk about the problems we are facing in our China data center operations, and how to leverage the CI/CD workflow and tools in our data center. This diagram shows the basic workflow of OpenStack CI, and the OpenStack CI is very different with other CI workflow. It introduced a new called a score code review system. Instead of directly submit the code into the version control system, the developer first submit a patch into the code review system, and then it will trigger the check test pipeline. The check test will run a bunch of check tests. It will give a score after finish it. If the test passed, it will give a +1 score, and if it failed, it will give a -1 score. Also, if it failed, it will give some like job logs back to the developer. They can check what's the problem and try to fix it as soon as possible. In this workflow, it also needs the developer to review the review and score the patch. The core developer needs to check the patch if they can. If they thought the patch is good enough, it will score the patch with +2. And if they thought this patch is not good and needs some work to do, it will give a -1 score. And it will also add the comments to the patch, and the developer can communicate with the comments with the code reviewer until it's fixed. Only if the check test plus 1 and get 2 more code reviewer to score the plus 2, this patch can be approved by the code reviewer. And then it will trigger a test called the git test. The git test refers to the process of running regression tests before submit patch against the source code repository to provide it will not introduce new bugs. Also, the git test is to make sure that the duration of the check test between the check test and the code merge to the code review system, before merge to the version control system, during this period, there is some new bugs introduced. Also, there are some other job queue added to the git test based on some projects. After git test finished, it also will get a score. If get passed, the code will merge to the master trunk of the version control system. I didn't mention this diagram there are also another post-queue jobs in this workflow, like to generate some documentation automatically. To implement this workflow, the OpenStack infrastructure consists with this workflow. You will submit local changes via the git-review command line, and the code will go to the Gerrit code review systems. Then it will trigger the integration pipeline management by the Zoo tool. And the Zoo communicates with the Jenkins master through the Gearman server, and the Jenkins master runs the jobs through their slave nodes. Also, the slave node is managed by a tool called the node pool. The node pool is like a service used by the OpenStack infrastructure to manage many DevStack images on the cloud server for use for the OpenStack project testing. Currently, there is some changes during the Zoo v3 released. It came out a new way use the Zoo v3 to instead of the Jenkins master-slave CI system. The Zoo v3 can directly communicate to the node through the Ansible plain book. Okay, what problem we have faced in our Oracle Public Cloud China Data Center DevOps? Actually, we have faced many problems earlier. First, it's hard to manage the DevOps development code. We have developed a lot of script to run our daily jobs, but with the code base increased, it's hard to manage, and it's hard to trace the bugs. So it needs a tool to manage our scripts. Also, in our team, we didn't have a standard workflow for the DevOps development. Currently, in our team, it just just manage the script under a server, and we want to leverage some open source way to implement some workflow. OpenStack is one of practice. We try to do it. Another problem is rapid changes of Oracle public cloud components. In our cloud environment, we have many components under our operation. But we also need to add more components in the later. So we need to get a solid efficiency workflow to give us the more strong automation works. Yeah. How to leverage the OpenStack way? First, the OpenStack workflow and tools are all open source, so it's free available to use it. We try to get some tools into our environment. This diagram shows the workflow we use in our China data center. First, we use one internal Git repository to management our operation script, and we involve the code review system Garrett for the code review, and use the integration management tool Zuo to schedule and report the test pipeline. Also, we use the Jenkins to manage the jobs. We also include one tool called Jenkins Job Builder. We try to automate our operation jobs with a YAML file, so it will be easy to run by the Jenkins. As a backend, you can see that is the red part. We have put it together in our managed host. As a backend, we have 3 types of hosts to run the jobs. One is called the test host. It is a test system to run all our tasks without any without any errors. So the errors will not influence our production system. Before we run the jobs on our production systems, we also have a stage host. It's called a pre-production system. We are running again the jobs for before to run it on the production host. Currently, we have leveraged following OpenStack tools. We have used Git for the version control system, and we use Garrett as a code review system. We use Zuo for the integration pipeline management, and use Jenkins for the CI tools, and use Jenkins Job Builder to automation our jobs. In the later, as the Zuo V3 released, we have some plan to implement some part, use Ansible and Zuo V3 to replace Jenkins. The Ansible is a configuration manager tool to run jobs on our managed host directly. We also involve another tool called Terraform. As in internal Oracle, we have some, we have many team, we have many team try to build and change the infrastructure use Terraform. So we want to align with the whole overall infrastructure, so we can integrate our service into the Terraform part. So for OpenStack part, as it's all open source, so you can get all the tools free available. Also, under OpenStack projects, there is another project called the OpenStack CI. This project is created to help the third-part project to leverage the OpenStack CI/CD workflow and tools, and to use it in their own system or in their own projects. Okay, I think that's all my talk about. If you have any questions, I think I have 4 minutes.
I noticed before you had Gerrit and Jenkins as part of your infrastructure up there. Do you have any resiliency in those services, or are they merely individual virtual machines there?
Currently, we run our test. The test node is a virtual machine, and actually the production and pre-production host is all real machine. So we didn't use container currently.
Sorry, I couldn't hear that last bit. You were saying you didn't use continuous integration.
Container.
Sorry?
Container orchestration.
Okay, thanks.
Any other questions?
Okay, this is my contact. If you have any question, you can free to contact me. Thank you.
Okay, thank you.